Hello students. So today we will discuss about surface segregation. Surface segregation is one of the ways by which atoms or molecules arrive at a surface and become at the surface and absorbed by diffusion around the bulk and become absorbed at the surface. Now this will happen when uh, the impurity, either the impurity is higher or lower concentration at the surface. That is why to maintain the similar concentration, the bulk atoms will go. So this is the surface, and there are bulk atoms here. The concentration of impurity at the surface is much higher, for example, than in the bulk. So this will cause the bulk atoms to migrate to the surface to maintain a similar concentration. This is one of the ways by which surface segregation can take place. Or instead of, or it may so happen that instead of impurity, there are binary or more complex alloys at the surface, then also it will invite surface segregation. Now, if the minority concentration is more, then we will call it the solute segregation. If the majority concentration is more, we call it solvent segregation. That means if there are, say, A and B atoms, where A is the solvent and B is the solute. So if the concentration of A is high at the surface, automatically there will be segregation of B atoms. The B atoms will go, and vice versa if the segregation of, so that in that case we will call it a solute segregation. And if it is the other way around, we will call it a solvent segregation. Now this surface segregation has a great importance in metallurgy. And there are, for examples, where, for example, embrittlement of an alloy. Can take place by segregation of impurities to grain quantities. This is another example. And the second example is corrosion, which also gets highly affected due to surface segregation. Now, the theory of surface segregation, or the thermodynamics of the surface segregation, was given by William Gibbs. And the theory behind surface segregation in dilute binary alloy was given by Abraham Bundle. Given in 1981. Now, according to the theory, as the sizes of the two atoms in the alloy may be different, there will be a difference between the strain energy of the solid when atoms are randomly distributed. So, when the size of there are two atoms, E and B, now as the sizes are different, also there will be difference in strain energy, so it will lead to a difference in strain energy. When the atoms are randomly distributed, so there are two possibilities. When these are randomly distributed, first of all, and concentration of one of the atoms is more than the other. So in these two cases, the difference in strain energy will be high. Now, this is the first postulate given by Abraham Bundle, and this is true for this AB atom. The second postulate is the strength of the bonds between the atoms of one kind and those of the other kind will be a little bit different. So this is the first one. I will call it as 1. Sizes are different. The second one is bond strength are different. So this again implies that by breaking bonds with low binding energies and forming more bonds with high binding energies, the free energy system can reduce. So breaking bonds with low binding energies and forming bonds with higher binding energies, it will ultimately reduce the free energy of the system. The bond breaking provides a driving force to cause surface diffusion. So that is why so this will again lead to the bond breaking and cause the diffusion of one of the species towards the surface. Now, if we look upon the pairing of the driving forces, so we know that there are EV atoms. If we consider EV atoms, and if we now concentrate on the pair of driving forces, then the total potential energy of the system in a solid solution tries to get minimized, so which actually allows the position of the atoms around the solid atoms to be relaxed. So the concept is minimization of the total kinetic energy which brings again to the fact that the allowed positions of the atoms around the solid atom to be relaxed, of the atoms around a solid atom that gets relaxed. So if we consider that there are there is a solid atom, and which is surrounded by solvent atoms. Then what happens is that the solid atoms gets relaxed surrounding the solvent atoms are relaxed around the solid atom. So these are the solvent atoms, or say and the same thing can happen on the surface as well. If instead of the solid atom presenting at the bulk, if it is at the surface, then a similar thing will take place, but with a different mechanism. So if this is the surface and the solid atom is present here, so this is how the solid atoms will be slightly less relaxed compared to that in the bulk. Now the surface tension ratio. Now, so this will lead to something called the surface tension at the surface. Now the surface tension ratio is gamma prime of pure elementary material. It reflects the contribution of the surface free energy. It reflects the contribution of surface free energy. Whereas the ratio of the atomic sizes they contribute to the lattice strain energy. Now let us define this quantity as gamma star, and this quantity as sigma star. So if we now plot gamma star versus sigma star, when we will get a plot like this, values say are 1.1, 1.2, 0.9, 2.7, 1.2, 1.5. So this area, there are four quadrants here: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And this quadrant where the concentration is low, whereas the concentration ratio of atomic masses is high. This corresponds to solute enrichment. But this boundary signifies that there is a bond breaking taking place, and also there is a nonlinear elasticity. So coming to our next vision. So this quadrant represents solute segregation, whereas this quadrant where both the surface tension is high and the ratio of the atom is also high. This indicates surface solute enrichment. This region, on the other hand, the quadrant 1, this is the one which represents solute depletion. Let's put it here. Whereas this one, this will represent solvent enrichment. So the only this shaded area only this is only this area, this one, where the solvent atoms segregate to the surface. Solvent, they segregate to the surface, whereas elsewhere the solid atoms segregate to the surface. Elsewhere, the solute atoms segregate to the surface. So it depends upon the surface tension ratio and the atomic size ratio. So with this diagram, it is possible to estimate the position of any particular dilute alloy in the plot. So this is the theory given diagram of an membrane.